We're continuing to solve compound inequalities, and once we find the solution intervals for those compound inequalities, we're plotting them on a number line so we can get an idea of what the solution graph looks like. Now in this video we're going to be dealing with some rather more complex compound inequalities, but it's actually nothing we can't do, so I just want to be sure to take it one step at a time. So we have the first one, we have 5x minus 8 is less than or equal to 2x plus 10, which is less than 4x plus 7. All right, now don't get excited about this. We still have just 3 terms here. And what we can do when we have something like this is we can split them up and deal with 2 terms individually. So we can deal with this one first, and then we can deal with these 2 second. So we're still dealing with the middle term, and we're dealing with both terms on the outside. So let's just do 2 at a time. So let's take this first set. We have 5x minus 8 is less than or equal to 2x plus 10. Okay, we know how to solve this. We simply move our variables to the left and get everything else on the right. So let's go ahead and subtract both sides by 2x. And in the same step, we can add 8 to both sides. We're just doing 2 steps in one here. These 2 terms cancel, as do these. 5 minus 2 is 3x, is less than or equal to 10 plus 8 is 18. Divide both sides by 3 to isolate our variable, so we get x is less than or equal to 6. Okay, so we got one inequality notation for these 2 compound inequalities, or this compound inequalities for these 2 terms. So now let's look at these 2 terms. Let's see, we have 2x plus 10 is less than 4x plus 7. We're just taking something rather complex and splitting it up to make life easier on us. Let's go ahead and isolate everything, our variables to the left and everything else on the right. So we can subtract both sides by 4x, and we can do 2 steps in one, subtract 10 from both sides. Okay. These 2 terms are going to cancel, and so are these. So we have minus 2x on the left, less than 7 minus 10 is minus 3. Let's go ahead and divide both sides by minus 2 to get x by itself. We can do that as long as we flip the inequality sign. So we have x is greater than instead of less than. We're dividing by a negative, so we're flipping the sign. These 2 signs cancel, these 2 negatives, so we have a positive 3 over 2. Okay, so now we have x is less than or equal to 6, and x is greater than 3 over 2. So what we're going to do is we're going to come back and put these together. We know that x is greater than 3 over 2, and x is less than or equal to 6. Now notice we started off with an AND compound inequality. We're going to finish with an AND compound inequality. We're not going to say x is less than or equal to 6 or x is greater than 3 over 2. We're going to finish with an AND inequality. Okay, so I hope that makes sense. We start off with the same thing that we finish, the same type of compound inequality. So let's go ahead and see what this looks like on a number line. All right, we're going to have 6 here, 5, 4, 3, 2, 1, all the way to 0, 2, 3, okay, and such. All right, so we know that all of our values for our solution interval are contained between 3/2 and 6. So we're going to put, we're not including 3/2 in our interval, so we're going to put a parentheses at 3/2 or 1 1/2, which is about right there. And we're looking at all the values to the right, or all the values greater than 3/2, so it's opening to the right. We're also interested in the values that are less than or equal to 6. So we're including 6 in our interval here, so we're going to put a bracket right here. We're opening to the left because we want all the values less than 6. So we just shade in between, and that's our solution interval on a number line. Okay, not a whole lot to it. We're not using any trickery or nothing like that. We're simply splitting these up to make it easier and then put them back together. But we have to make sure that we do indeed put them back together. So let's take a look at the next one. The next one we have is 7 minus x is less than 2, or 2x plus 6 is less than 5 plus x. All right, so here we're encountering our first OR compound inequality that we want to solve for. So we'll actually solve compound inequalities that include OR the same way we did with AND. Only here our inequality is already split into two separate inequalities. So that actually makes life much easier for us because we don't have to pick which one we want to do first. So we'll deal with this one, and then we'll deal with this one separately. So we have 7 minus x is less than 2. Let's go ahead and subtract both sides by 7, getting everything else on the right and our variable on the left. Those two terms cancel, so we have minus x is less than 2 minus 7, which is minus 5. Let's go ahead and divide both sides by minus 1. We can do so as long as we flip the inequality sign. So now we have x is greater than, if we cancel these two negatives, greater than 5. So here's one of our inequality notations. All right, so let's take a look at the next one. So we have 2x plus 6 is less than 5 plus x. Okay, so we want to get our variable on the left-hand side and everything else on the right-hand side. Okay, so we can start off by subtracting x from both sides, and at the same time, if you want to, we can subtract 6 from both sides. We'll do 2 steps in one. These two terms cancel, these two terms cancel, so we have 2 minus 1 is just x, less than 5 minus 6 is minus 1. So now we have two inequalities, but this one is actually going to be OR because we were started out with OR. So we have x is greater than 5 or x is less than minus 1. All we simply do now is graph it on a number line, and we have our solution graph. So this goes in the negative direction, this goes in the positive direction. We have 5 here, 4, 3, 2, 1, 0, minus 1. Here's our minus 1, and we know that we're going to have two different shaded regions because this is an OR compound inequality. So let's start from left to right on the number line first. So we have x is less than minus 1. So we want all the numbers less than minus 1 or to the left of minus 1. And we're excluding minus 1, so we put a parenthesis here. We're not including that in our solution interval. Okay, now we want all the values that are greater than 5, but we're excluding 5. So we're going to put parenthesis at 5, opening to the right, and shading to the right, because we want all the values greater than 5. And that's all there is to it. Okay, so that one actually took a little less work. Most of the work was already done for us. Let's go ahead and look at a couple more. Let's say we have x plus 1 divided by 3 is less than or equal to 4x, or x plus 1 divided by 3 is greater than 3x minus 2. Okay, so this isn't anything to get excited about. We'll just deal with one at a time. So here we have x plus 1, sorry about that. We have x plus 1 divided by 3 is less than or equal to 4x. All right, so we want to get x by itself. So let's go ahead and divide through the entire inequality, the entire compound inequality. Let's multiply through by 3. That'll get rid of this fraction here. So this will cancel. So we have x plus 1 on the left-hand side, which is less than or equal to 3 times 4x is 12x. Let's move our variables to one side. So let's go ahead and subtract 12x from both sides. Minus 12x. That cancels, so we have minus 11x plus 1 is less than or equal to 0. Let's go ahead and subtract both sides by minus 1. So we have minus 11x less than or equal to minus 1. Divide both sides by minus 1 to isolate our variable here. Those cancel. So we have x. We're going to flip our inequality symbol because we're dividing by a negative. So we have greater than or equal to. These two negative signs will cancel, so we have a positive 1 over 11. Okay, so that's one of our inequalities. The next one, this is an OR problem. The next one is x plus 1 divided by 3 is greater than 3x minus 2. This looks pretty similar, and we'll actually start it out the same way. Let's divide the whole inequality by 3. That'll cancel the denominator here. So we have x plus 1 on the left-hand side, greater than, now we have an expression over here, not just a term, not just one term, we have 2 terms over here, so we're going to have to multiply both of these by 3. So let's go ahead and write this step out. So we have 3 times the expression 3x minus 2. We can distribute this 3 into the parentheses. We could have done it straight from here, but I just wanted to make sure that there's no ambiguity, we're not missing anything, just added this extra step. So we have 9x minus 6, and we can go ahead and go about solving for our x. Let's subtract 9x from both sides. Let's move our 1 to the other side in the same step. These 2 terms cancel, as do these. So we have a minus 8x is greater than, minus 6 and minus 1 is minus 7. Let's go ahead and divide both sides by minus 8 to get x by itself. So we have x is greater than, if we cancel these 2 negative signs, x is greater than 7 over 8. Okay, so, actually, we needed to flip this sign here. We're dividing by negative 8, so this is actually going to be x is less than 7 over 8. Whenever we're dividing by negative, we flip the inequality sign. And that's our second inequality. So we have 2 OR inequalities, so let's go ahead and graph them on a number line. We should be getting pretty good at this by now. And this is actually going to be zoomed in quite a bit because our values are fairly small. All right, so we know that x is greater than or equal to 1 over 11. So we're looking for all the values that are greater than 1 over 11, but we're including 1 over 11. So that should be somewhere right here. We're going to place a bracket because we're including this point in our solution. We're also looking for all the values that are less than 7/8. We're not including 7/8 in our solution interval, so we're going to put a parentheses, and it's about right here. And then we just shade in between, and that's our solution interval. All right, well, we're running out of time. We have a couple more exercises to do, so I'll see you in the next video.